Okay, imagine an AI, not just recommending your next buy or, suggesting a song, but one that genuinely thinks like you.
Mm.
What if AI could actually mirror your unique thought process?
That's a fascinating idea, and that's exactly the territory we're getting into today.
Right.
We're doing a deep dive into a really novel approach to AI. It's centered around these knowledge maps that are defined by you, the user.
Exactly. We've been looking at this really compelling piece. It's called AOAI,
Uh-huh.
which, translates roughly to personalized AI based on knowledge maps. And it has this interesting subtitle too, regarding the structural innovation for designing user-centered AI.
Yeah, that subtitle really captures it.
So our mission today is to try and understand why current AI personalization often feels, well, a bit flat, maybe, not truly personal.
Right, impersonal even.
Yeah, and then explore this alternative where you actually design the AI's thinking framework. Okay, so let's unpack this.
Let's do it. Because, when we talk about personalization in AI right now, what are we really talking about?
Mostly tracking.
Pretty much, it's algorithms tracking what we do, what we click, what we buy, what we search for,
Yeah, think about your streaming service suggesting shows. It's just based on what you watched before.
or your news feed.
Oh, definitely. Filled with articles just like the ones you already read. It's all built on that digital trail we leave.
And look, that can be useful,
Right.
sure, convenient, but the key point the source makes is this isn't truly reflecting your way of thinking, your cognitive framework.
It doesn't get the why, does it? Like why I clicked that thing or the angle I was coming from.
Exactly. It doesn't understand your specific perspective or the criteria you use.
So it's like the AI is just reacting based on its huge pre-existing data set, its own sort of general worldview,
Uh-huh.
not my specific way of connecting ideas or my language or how I structure things.
Precisely. It operates within its pre-baked structure. It doesn't inherently grasp how you link concepts or, the hierarchy you assign them.
Which makes this idea of a personal knowledge map. Well, it sounds like a totally different game.
It really is.
So what is the alternative then? How do we get beyond just reacting to history?
Well, the core innovation here is basically flipping the script entirely.
Okay.
Instead of the AI just passively learning about you from your data trail. The idea is to empower you, the user, to actively design the AI's thinking structure.
Right. Through this personalized knowledge map.
Exactly.
Okay, so a knowledge map, what does that actually look like? What am I doing as the user?
Think of it like creating a blueprint for how the AI should organize information, but it's your blueprint.
Hmm.
So a couple of key things. First, you define the labels for concepts, whatever terms make sense to you.
Okay, so instead of the AI's built-in categories, I can make my own, like for music, maybe focus tunes and weekend road trip jams, using my own words.
Yes, precisely your own words. And second, and this is crucial, you design the relationships between those labels.
Ah.
The source mentions a tree-like structure.
Hmm.
So you're building a hierarchy, maybe food at the top, then branches to fruit and vegetables, and fruit branches to apple, banana, etc.
Right, right. So I'm basically building my mental model of a topic, but I'm building it for the AI.
You got it.
And the AI then learns to think, to reason, using that structure I made.
That's the core idea.
Okay.
It's trained to navigate and understand the connections you've established. It categorizes, it makes inferences, all based on your framework.
Wow.
So yeah, just to stress it again, you're not just giving it data points. You're essentially handing it its fundamental reasoning system.
That is, yeah, that's a big shift. Okay, so we have this user-defined blueprint. Let's get into the nuts and bolts. How does the AI actually use this map? What are the components?
Okay, yeah, the architecture is interesting. The source breaks it down. First, you've got the inductive model. Think of this as the part that still does the basic learning from data, like recognizing a picture of an apple is an apple.
So it still needs data examples.
Right. But then, crucially, it places that apple within the structure you've built in your knowledge tree.
Ah, the tree structure we just talked about, my hierarchy.
Exactly. Your user-defined hierarchy. Now, the really clever part is how it uses this tree. It's called deductive route recognition.
Deductive route. Okay.
So once the inductive part recognizes something, say an apple, the system can then infer related stuff by moving up and down your tree.
So if it sees apple, it knows fruit, it knows plant going up.
Exactly. And it works the other way, too. If it knows something is generally a fruit, it can understand apple fits as a specific example below it, general to specific, specific to general.
Okay, that makes sense. It's reasoning based on the connections I made. What about these multi-model configurations mentioned?
Ah, right.
Yeah.
That's not accuracy. It's pretty smart. Instead of just one AI model making the call, the system uses several models working together.
Oh, like different specialists?
Kind of. You have low precision models looking at broad concepts, medium precision for, well, the middle ground, and high precision models focusing on the very specific details.
So different levels of focus on the same information.
Exactly. And this leads to the next bit, reliability filtering.
Okay.
The system only accepts a result, a classification, if there's an overlap in the predictions from these different models.
Ah, so if the broad view model and the detailed view model both agree it's an app.
Then it's considered reliable, yes. If they don't agree, the system might hold back or indicate uncertainty. It's like needing a consensus.
That sounds much more careful, more robust than just one model taking a guess.
It aims for higher precision, definitely.
The source also had some really cool examples about how this system generalizes. Can you walk me through those?
Yeah, they really illustrate the power here. The first one was learned category generalization.
Okay.
So imagine the AI is only trained on pictures of white Arctic foxes. That's all it knows specifically. Now, you show it a picture of a gray Arctic fox, something it's never explicitly seen.
What does it do? Does it get confused?
No, this is the cool part. It doesn't just guess wildly, it correctly recognizes it as animal and mammal,
Yeah.
the higher levels in its knowledge tree that you defined.
Uh-huh.
But for the more specific level, maybe related to color or subtype, it identifies it as an undefined sublabel.
So it knows where it fits generally, but acknowledges it doesn't match the specific examples it learned. That's subtle.
It is. The source calls it inference power. The AI can effectively say, okay, this fits the big picture, but the specific detail here isn't one I was trained on within this category.
More useful than just error. Not found.
Much more. Okay, the second example. Reaction to new unlearned categories.
Right.
Here, let's say the AI is trained on butterflies, ants, and mantises, all insects within its tree.
Okay.
Then you show it a ladybug. It's an insect, but maybe ladybug wasn't a category you explicitly defined or trained it on.
So a totally new type of insect for it.
Exactly. Again, it shows partial recognition. It correctly identifies it as animal and insect based on the structure.
Because it knows the higher levels.
Right. But it doesn't try to force it into butterfly or ant. It stops at insect because ladybug isn't a defined subcategory it knows.
So again, it shows that sort of cautious judgment. It recognizes what it can based on the structure, but doesn't overstep into guessing specifics it wasn't taught. It knows its limits.
Precisely. And that's a big difference from, say, some other AI models that might just try to cram the ladybug into the closest existing category, even if it's wrong.
Yeah, I can see that. This whole approach feels fundamentally different.
Yeah.
The source even laid out a comparison table, right? Between this and traditional AI like GPT.
It did. It's useful to see it side by side.
Let's run through those key differences. Personalization method.
Okay, traditional AI relies heavily on your user history, your past behavior.
Right.
This system, personalization comes from the user-defined knowledge structure itself, the map you build.
Okay. And the model design.
Traditional AI, like ChatGPT, often a single huge general model. This system uses that collaborative multi-model structure we talked about, low, medium, high precision, working together.
Got it. What about how they reason?
Traditional AI,
Right.
mostly similarity-based induction, finding patterns in massive data.
Okay.
This new system, it combines structure-based deduction using your knowledge tree
Yeah.
with induction from the specific data it sees, both methods.
And controlling accuracy.
Traditional models often use statistical methods like softmax, maybe some filters after the fact.
Right.
This system uses that reliability filtering, needing the intersection, the agreement between its multiple models for a precise result.
Okay, this next one feels huge, reflecting the user's perspective.
Yeah, this is arguably the core difference. The source says traditional pre-trained AI can't truly reflect your unique perspective. It has its own learned worldview from its training data.
But this system...
Because you define the concepts and structure,
Yeah.
it can reflect your perspective, your way of organizing knowledge.
That's a major claim. And explainability. The black box problem.
A big difference there, too. Traditional AI reasoning can be very opaque.
Yeah.
Hard to know why it gave an answer.
So the box, yeah.
But with this structure-based reasoning, you can potentially trace the logic back through the knowledge tree you designed.
Well.
So much higher potential for explainability.
So you can see how it arrived at the answer based on the rules you set, that transparency. Yeah, that could be incredibly valuable.
Definitely.
Speaking of value, where could this actually be used? What are some real-world applications?
Oh, the potential is really exciting. I mean, first off, imagine a truly personal AI assistant,
Okay.
one that doesn't just take commands, but actually thinks using your concepts, your priorities. It can anticipate needs or make connections in a way that perfectly aligns with how you reason.
That would be amazing compared to current assistants. Much more intuitive.
Absolutely. Or think about
Like
educational.
AI tutors.
Exactly.
Hmm.
But tailored AI tutors. If a student organizes information or connects ideas in a particular way, you could design the AI tutor's knowledge map to mirror that student's structure.
So it teaches in a way that matches how the student learns best.
Precisely. Adapting explanations, examples,
Right.
making it truly personalized learning support.
That makes so much sense. One size fits all just doesn't work well there. What about specialized fields, like medicine or law?
Huge potential there, too. You could build expert systems for diagnosis or legal analysis, where the AI's knowledge map reflects the established conceptual structures and decision-making hierarchies used by experts in that specific domain.
So, like a medical AI that reasons through symptoms following the same logical paths a top doctor would use.
That's the idea. Potentially more accurate, more reliable, and importantly, more explainable insights.
Wow. The source also mentioned assistive systems for people with disabilities.
Yes. By learning an individual's potentially unique language structure or their specific way of expressing concepts.
Which might differ significantly.
Right. An AI helper could be built based on that individual's learned structure. It could understand and respond in a way that's truly natural and effective for them. Much more seamless support.
This is all leading towards that final point the source made, which felt really profound, about AI actually learning your thought process.
Mhm.
It said, past AI could mimic language, even judgment to some extent, but we couldn't really make it think like one specific person.
And that's presented as the core breakthrough here. This technology is explicitly designed to allow an AI to think like the user.
How does it achieve that again?
The mechanism,
Yeah.
as the source puts it, is layering that inductive AI, the part that learns patterns from data, on top of these user-designed knowledge trees and reasoning structures.
Ah, right. The data learning combined with the user's framework.
Exactly. It's about giving the AI a cognitive blueprint that is uniquely yours.
So the big takeaway here really feels like this potential fundamental shift, moving from AI that just learns from your data to AI that can actually learn your way of thinking.
Yeah.
That feels like a massive leap towards truly personalized AI.
It really does. And, it leaves you with a pretty big question to think about.
Hmm.
What are the implications if you could genuinely define the core structure of an AI's understanding? How might that change how you interact with technology? What kind of insights could you get when an AI truly reflects your own cognitive landscape? What new possibilities open up then?